Hi guys, thank you for attending our 10th Angular.love meetup. My name is Gregory and I'm here with you as an Angular enthusiast representing Angular.love community that organized this event, of course. We are streaming from Warsaw, Poland, but I'm also curious from which city you are watching us, so let us know in the comments below from where you are watching us. And before we start, I would like to provide you with some information. First of all, today we'll have two talks, and after each talk, there will be a Q&A session. So feel free to write your questions in our chat, so our colleagues could answer those. We also prepared contests for you regarding the contest. Details are on the screen, and there's an option to win our epic red sweatshirt, which you know from our conferences. We would also like to thank House of Angular, sponsor and our partner. House of Angular team provides consulting and Angular code audits, so feel free to contact them if you struggle with your project or you want to start a new project with a good manner and have a nice development standards there, so on. Okay, I think we are ready to start. Dawid Kostka, which is here with me in Warsaw, will talk about the bright future of Angular signals, and I would like you to give him a warm welcome because this is his first talk like that for such big audience. And yeah, enjoy your talk, and we see each other after the Q&A session.
Hey everyone, welcome to our meetup. Today we're going to discuss the bright future of Angular signals. After this lecture, you will know what are signals, what value do they bring to Angular framework, and the most important one, how they are going to impact our daily tasks. Let me quickly introduce myself. I am Dawid Kostka and I'm an Angular developer at House of Angular. I'm also a technology aficionado and an aggressive online skater. So, as you know me, we can go to the meetup itself. Let's start with the signals, or shall we? Before we speak about the signals, in my opinion, we should briefly discuss the topics like change detection, component rendering, and the ZoneJS. In my opinion, knowledge of these topics is important because without that, you won't be able to understand why the signals were created in the first place. So let's start with the ZoneJS. What is a ZoneJS and how does it work? ZoneJS is Angular's signaling mechanism that notifies Angular every time an event finishes in the browser. Every time Angular gets that response from the ZoneJS, it will trigger the change detection cycles that then check the components and render our UI. Thanks to the zone, that is a great tool, we get that automatic rendering feeling. Everything seems to update just in time and on time. But unfortunately, the ZoneJS has a few cons. First one of them is that the ZoneJS slows down the initial app runtime. Before any Angular code can be run, the ZoneJS must be firstly loaded and properly running in the browser. Another small cons of the ZoneJS is that it slightly impacts our bundle size of our application. Because of that, our applications have a larger size than they would have without the zone, that in my opinion won't be needed in 2 years. So let's go to the last biggest con of the ZoneJS. It's informing behavior. This is the biggest problem of the zone because it only informs Angular that the changes have been made, but it doesn't tell it where they have been made. And because of that, Angular has to overcheck those components And because of that, we get that performance that could have been used somewhere else. Imagine that you're executing an event every time a user moves the mouse. And in that time, the change detection is run often 100 times a second. That's a pretty big number, isn't it? In those cases, we might want to patch the ZoneJS in the polyfills config. It allows us to handle the change detection manually, and because of that, we might get that best feeling of the performance of our applications. Unfortunately, this also has a con, and it is that we have to manage that change detection cycle manually. And we should ask ourselves a question whether it is the way where we want to get the performance, but we lose that great developer experience. Okay, so as we know the zone, let's go to the next topic, that is change detection. Change detection is directly related to the zone because it triggers every time a zone notifies a change in the browser. So let's start with the default change detection. As you can see, the default change detection is run every time a zone detects an event in the browser. Here, after the user clicks in a button, then the component tree is rendered. It is the default change detection cycle that often is not very performant, and because of that, we wouldn't use it in default applications such as large enterprises applications. So as we know the default change detection, and we know that we shouldn't use it at all in most cases where we build real-world applications, not tutorial apps, what should we use then? And here comes the on-push change detection. It's an enhanced version of the default change detection where only the components that have been updated and marked as dirty are updated. Okay, so as you know that on-push change detection is a little bit more performant. Why is it? It is because the on-push change detection only checks those components that are marked as dirty. Okay, so let's go to the next slide. And in this one, we'll learn even better strategy than the on-push change detection. And it will be the zoneless applications. The zoneless applications allow us to get rid of the zone and introduce isolated change detection systems. As an example of that, we can use the RX Angular library that allows us to introduce the isolated change detection system. And thanks to it, we are able to have that extra grasp of the performance. It is a perfect solution for those applications that struggle with the on-push change detection. And in those cases, we have to do more stuff manually. And because of that, we should ask ourselves a question, whether choosing a zoneless application is worth it. So at this time, we had only those three approaches. And soon, the signals will introduce another one, the signal components. But firstly, let's talk about what is a signal. And a signal is a primitive reactivity structure that holds a value that changes over time. The signal allows us to subscribe to it like the observable patterns do. And because of that, it's built on the subscriber-publisher pattern. We can call a signal a small cousin of the behavior subject. They seem to work similarly, and both allow us to access the value of a signal in synchronous way. But those two have differences, and they are not equal. So before we speak about the differences between those two, let's talk about the signals API and how we can create the signals. To create a signal, we use the signal function that takes two parameters. The first one of them is an initial value of the signal, and the second one is the signal options. So as we've created the numbers signal, as you can see on the screen, we are able to read that signal by using argumentless function call, as you can see in the third line. Here, we're reading a value of a number, 5, and that is the text that would be the result of this code. So, as we know how to read and create the signals, we can go to another technique that will allow us to conquer those beasts. It is modifying the signal value. In the world of signals, we have 3 different methods that allows us to modify a value of a signal. The first one of them is the set method. Second one is the update. And finally, the last one is the muted method. All of those methods works differently and have different use cases. Let's start with the first one, the set method. The set method allows us to override the current value of a signal. And because of that, we can use it in utility functions such as reset counter, set counter value, or reset users. It is a perfect solution where we don't need to access the previous value of the signal. And what if we would? In that cases, we can take advantage of the update method. As you can see on the code block on the left side, in the update method, we are passing the arrow function. That first parameter is a previous value of the signal, and return type of that arrow function is a new value of a signal. The update method is a perfect solution, especially if we will use it with the immutable data approach, as you can see it on the right side. In the utility function addUser, we're updating current user's signal value by creating a new array, restructuring previous users, and adding a new user. So, speaking about immutability, let's talk about the different approach. The mutate method allows us to access current value of a signal and execute methods and access the indexes of it at the runtime. As you can see on the left side, we are getting access to expose user's signal value, and we are allowed to push a new user to it. Or like on the right side, we're also having that user's signal, and we are accessing its index by replacing the user added. So those two are pretty great, don't you think? Let's talk a little bit about the cons of the mutate method. The JavaScript compares the value of the signals using the free equals operator. That's how it's implemented in Angular. And because of that, by using the mutate method, we expose ourselves to bug where the signals won't be detected as changed. And as a cause of it, I wouldn't use that method pretty often until I would know that the signal will be updated after some time. If I were you, I would stick to the update and set methods and take advantage of them. Okay, so as we know the mutate method and all of the core building blocks, like reading, creating signals, and writing a value to them, we can go to the next topic and build something with signals. Guess what? We'll build signals with signals. Yeah, that's real. On the code block on the left side, you can see that firstly, we're creating a first name signal and last name signal. Below that, we're using the computed function to create a signal that is built of other signals. Here, in that factory function, we are using the first name and last name signal to create full name. The value of a computed signal will be updated every time a value of the child signals or input signals changes. Okay, so as you can see on the right side, we also have that getter. And what is going on with it? In my opinion, those two approaches can be kind of compared together. Why do I think like this? They almost work in the same way, but we can take advantage of the full name signal and its memoization. It's something that we didn't have in the getters that allows us to improve the performance of our applications. So I've created also one more example of the computed signals so you can get a better grasp on them. In the signal setup, we're creating user's signal that contains initially two non-admin users, Joe and Mark. In the sixth line, we are creating computed signal that filters out non-admin users. It is pretty easy, don't you think? Then, we are creating an addUsers utility function that updates the value of users by adding a new user to a new array with the destructurized users. So, as we were done with the setup, we can go to the logic. And here, we're console logging firstly the length of the admin users. And guess what? It's equal to 0, because initially, we haven't declared any admin. Then, in the addUser function, we're adding Jane, that is an admin, to the user's signal. And as you can see, as a result of that, in the 16th line, the length of the admin user's signal value is equal to 1. As you can see, the computed signal have automatically updated and its value is changed. So, As we take a grasp on the computed signals, we can go to the next topic, the effects. The signal effects allow us to react to value changes of a signal. As you can see here, we are firstly creating a signal with an initial value of 2, and we are assigning it to a read-only variable number. In the constructor, we are creating an effect that will print out the text number value has changed to the console every time the value of that signal changes. The effects can be seamlessly created in the injection context, such as the constructor or property initialization. They can be also created in the special Angular functions, for example, can activate, but in my opinion, I don't see use cases in them. So, as we know what the signals effects are, we can compare them to observables, and particularly that one type of observable that everyone compares to the signals, and that is the behavior subject. On the code block on the left and the right side, I've created the same logic that will be comparing those two approaches and show the difference between them. Firstly, we're creating a name variable that will hold our data. On the left side, we're using behavior subject to do this, and on the right side, the signals. In the constructor, we are subscribing to the value changes of that variable and our data, and then we're console logging the updated name to the console. On the left side, we're using the subscribe method of the behavior subject, where on the right side, we use the effects. Then, in the 8th line, we're setting this.name to Julian. And after that, we're creating a set timeout that after 1 second will set the name following to Mark and then to James. As you can see on the output of the left side is a little bit different than the output on the right side. And you may think, why is it? And I will tell you, that's because the signal effects are asynchronous. That means that they are executed at the end of the change detection cycle. In comparison, the behavior subject subscriptions are executed synchronously. That means they are printed every time the value of that observable changes. Keep in mind, though, that in future, signal effect execution time may change. Currently, there is a pull request on the Angular repository that will set that change detection execution cycle to the micro task. Okay, so as we've taken the grasp, let's talk about the use cases of signal effects. And the first one of them will be debugging. We can use them to log messages to the console. Then we can send API requests every time a value of a signal changes. We can also use them to synchronize the data with the local storage. They also will have use cases in executing DOM operations and performing custom rendering. Okay, so as we've taken through this slide and we know the use cases of effects, let's go to the next hot topic that is currently blowing up on the Twitter, whether the Angular signals are going to kill RxJS. Yes, everyone's talking about it. And in my opinion, Angular signals won't kill the RxJS because those two things have different ideas behind them. The Angular signals are used to store the data, where the RxJS is created to handle that data changes and react to it. Also, we won't replace the RxJS in Angular because it allows us to shorten up the code and use such utility functions as the bounce time. So, as we've taken through the slide, let's talk about the API. Angular gives us two utility functions that we can use to connect those two words together. Firstly, we have the toObservable function, and then we have toSignal function. We can use the advantage of toObservable function that I presented on the left side. Firstly, we're creating a signal number that holds a name. Then we convert it to observable number $. In the 4th line, we're subscribing to the number $, and we're console logging the output every time its value is going. Every time it will have a next value in the stream. In the 6th line, we're setting the initial value of the signal to 4. And as you can see, the logic in our subscription have executed. That means the operator works. Okay, so as we are done with the left side, let's go to the right side and talk about the toSignal implementation. As we can see, in our app component, we're injecting the food service. And below that, we are using its getFoodList method that returns an observable list of the food from API. We've wrapped that statement with the toSignal function that allows us to access that particular variable synchronously in the app component. That means we don't have to subscribe to it to get access to it. Another advantage of having that toSignal operator on the observable is that we can use it in the template without the async pipe. That is impure and decreases the performance of our application. Okay, so as we went through the basics of signals, computed operators, effects, and the conversion utilities, we can finally create something bigger. We'll create a new generation application that is built on the top of the signals and RxJS. As you can see on the GIF, firstly, we have the select that allows us to select a value of a post. We can select posts with different IDs, and the ID 1000 doesn't exist. In that case, we won't display the post data, we'll display the non-existing post template. And one more thing that you can see in this slide is that during the changing of the post, we're having the loading text. And it is that the user can see what is happening. Okay, so without further ado, let's get into it. And firstly, we will have to create our data model. We create the post interface that will have ID, user ID, body, and a title. Then in the post service, we inject the HTTP client that will be used in getPost method to execute a GET request to JSON placeholder API and get the post data. We are delaying that response by 500 milliseconds in order to see the loading text appearing in the UI. Okay, so as we have the service, we can go to the app component. And here, we are injecting that newly created service. Then, in the selected post, then we are creating two signals, selected post ID and is loading posts. They will be used as a primary storage point in our app component. Then you have that scary 7 line where we start creating our post data variable. And as you can see, it's pretty complex. Let me explain it to you. In the 8th line, we're changing the selected post ID to observable, so we can pipe it, and every time it changes, we can set the isLoading post signal value to true, so the loading text will be visible to the user. Then we take advantage of the switchmap operator, and we are executing a GET request. In case the server returns an error, for example 404, we set the value that is returned by the stream to null. And the last thing that we do after the request succeeds or fails, we are setting back the isLoading post signal value to false. So the loadings will no longer be visible in the UI. Okay, so as we went through that scare example, I would also like to say that we are converting that get observable to signal, so we can use it later on in the template. The last thing that we can see in the components is set selected post function that allows us to react to select changes and set a value of selected post. Speaking of the selected select, let's go to the template and explore it. Firstly, we can see that on the select change, we use the set selected post method, and we are setting a value of set selected post ID in the template. Our select has 3 options. The first one and the second one of them are existing posts from the API. The third one doesn't exist there, so it will return a 404 response. Okay, as we are done with the select, let's go to the ng container and explore its logic. Firstly, we check whether the isLoading post signal is true. In case it is, we're displaying the loading text to the user. In case it's not, we go further down the condition tree, and we are checking whether the post data is truthy. In case it is, we are displaying the post to the user, so he can see the post title and post body. In case the post data is nullish, that means the server returns an error in the request. We're displaying the non-existing post to the user. That was pretty simple, wasn't it? I know, at the start it can be a little bit confusing, but you'll get used to it. In this component, we use the signals as a primary data storage unit in our components. And you may think, why did we? And I will tell you that in the future, we'll get the signal components, something that works very similar to RxJS and allows us to introduce that isolated change detection system to our framework. It has many benefits. Thanks to that system, we'll be able to get rid of the zone and improve performance of our applications drastically. Okay, so as you know that, let's go back a year. Back to the ngconf 2022. Here, the Angular team introduced the underlying change detection system. They had asked questions like whether they can make Angular zoneless, introduce per component change detection, stores for state management, and computed properties. As you could see in this presentation, they're done with that logic almost. And those features have been introduced and will be introduced soon, like the signal components. Okay, as we stick to that slide, let's also see that rock on the right side. In my opinion, that symbolizes the current change detection system, and it slows down our applications. Let's get rid of that rock and introduce the signal components. But firstly, we should compare those approaches. Firstly, on the left side, we have the default change detection that is extremely imperformant and executes a ton of rendering. Then we are having that on-push change detection strategy that allows us to build large enterprises application and create stuff that simply works, but it's not the best as it can be. We can take advantage of the Rx Angular, but still, let's remember that it have good developer experience, but it's not the greatest that we can have. And there we come the signal-based components that are a perfect solution to our framework and will be introduced so we can work with them natively. Okay, now let's imagine that process of these red and blue dots and blue squares on a little bit bigger scale. Instead of 7 nodes, let's say that we will have 70 of them. As you can imagine, in that place, the default change detection won't work or will work very slowly. The on-push change detection will work, though we may start to see small imperformances. And in this place, with the large applications, the signal-based components will be a perfect solution. So let's go to the future and talk a little bit more about the future of signal-based components. Currently, in the Angular 16, we're having the signals in developer preview. That means that we shouldn't use them in the production applications, though we may getting familiar with them because soon they're going to be an integral part of every Angular developer. Okay, with the signals in a stable version, we'll be slowly able to create and change our application to signal-based components. And the signal-based components, unfortunately, won't be released in the Angular 17. We may expect them in Angular 18, and I'm pretty sure in a year from now, we'll get them. Okay, so finishing that signal component stuff, or maybe we shouldn't. In the future, after the signal-based components gets released, we'll surely get a lot of UI libraries that simply work and are based on the top of those components. Who knows? Maybe even the Angular material will use the signal-based components to improve the performance of their library. The signals will also be used to create state management solutions. On one of those solutions, currently is working the NGRX team that had presented to us Signal Store also in developer preview, so we can get a grasp of it. The last thing that we may expect from the signals is that they opened a gate to granular rendering in Angular. It's a common feature known from the solid.js that divides our template into small chunks that each of them uses a signal. In case the value of a signal changes, we only render that small little chunk in the template. Isn't that beautiful? It's even more performant than you ever could have get in the Angular. If the Angular team would introduce that feature, that would be perfect. And I'm waiting for it. Please make do it. I would also like to say that granular rendering that is implemented in the solid is implemented in the solid.js that is known to be one of the fastest framework on the market. Okay, unfortunately, this presentation slowly comes to an end. It's hard to cover the topic of signals in around 35 minutes. So the Angular.love prepared for you 2 articles. The first one, titled Angular Signals, a new feature in Angular 16, is currently available, and you can read about it at our Angular.love website. The another one, Why Angular Signals Won't Replace RxJS, will be released in the next week, so you can get something to read to the coffee. Okay, this is the end, and that will be it from my side. Thanks for your attention, and if you have any questions or you would like to show your opinion about the signals, feel free to post it on the chat. Okay, so I see one question, just let me find it. Somebody compare the behavior subject to the signals again. Okay, and the difference between those two is that the behavior subject loses that ability that gives us that the signal gave us. Basically, every time we try making a computed property with that behavior subject, we're calling even more stuff than we should. And the signals allow us to create computed properties. Behavior subject is very great, yet still it serves a little bit different purpose. The behavior subject will be used in situations where we want to react to every value change, where the signals will be used to store the value. That's quite a difference, and I wouldn't compare those two approaches together. They seem familiar at the plain level, but they're very deeply, they have different implementation, and because of it, they're simply different. Okay, so that would be it from my side. One more time, I would like to thank you for your attention. See you on the next meetup.
Okay, guys. Yeah, thank you, Dawid, for the exciting topic. I would like to also thank whole Angular team for providing us signals in Angular 16 and making Angular great again, as we laugh about it. But definitely it's significant thing for the community and for the all developers inside. Yeah, I would like to also remind about our contest. So feel free to post a picture with you watching the meetup on Twitter, and then we'll choose the best picture, and you can get a best epic red sweatshirt. And now I would like to invite our next speaker, Tomasz Borowski, senior Angular developer and founder of Angular in Space workshops and trainings for developers. And he will talk about how smart is your component. And yeah, that should be a great talk. Tomasz is a great developer as well. And give him a warm welcome. And of course, as before, enjoy the prelection, enjoy the speak. And we see each other at the end.
Hello, everyone. My name is Tomasz Borowski, and for the next, 30 minutes, we'll be talking about your smart components and what approaches we can have in implementing them, because there are a lot of them. So, in this presentation, I would like to show you what makes an Angular component smart, what are differences between smart and dumb components. We'll go through the real case scenario, which will include the view for displaying the space launches of SpaceX, to see different approaches for implementing smart components. We'll use the most basic one, which will be based on the single service from which we'll be reading data without actually observing too much. We'll see the resolver case. We'll go through the extensive using of observables. We'll take the experience that we had from the Dawid's talk to see how we can implement that in signals. And we'll also take a look how we can implement smart components with NGRX store. And at the end, we'll see the ultimate solution that will be probably the best from all those listed here. So this presentation and all the examples are available as an app. You can go to the smart.angular-in-space.pl to see this and to play around after this talk is over. Okay, so what is actually a smart component? So smart component is usually the top level component that is connected to the Angular route, and it's the component that injects the Angular services like our data services or store or activated route. And smart component gets data from those sources and delivers this data to the presentational components, which accepts those data through the input mechanism. And in this case, in this example, such a presentational components would be list component, filters component, and the pagination component. Those components are meant to display data, and if they need to change anything about the state of the data in the application, they do not do that by themselves, but they use the output mechanism to let them know, the smart component, that something has to be done with the data. So they actually can request sorting, filtering, or changing the page. Smart component will not be there for presenting data. It's all about the distribution of data and passing the events to the services which will handle data processing. In many articles on the web, you will see also another name, which will be container for these smart components, as this component basically contains other components. The reason for doing such an architecture is that we have an only single point of contact with the data providing services here in the smart component. And this data flow from the top to the bottom will allow us to improve performance by using on-push change detection strategy within the presentational components. Okay, so let's go through the example. So here are requirements that I had when I was implementing these examples in different approaches. So we have the list of the space flights of SpaceX. We support data filtering with this filter component. We display the status indicator, so we know if data is being loaded or is there any error. And we can use pagination to switch pages, and we can see the total number of results that are there on the API side. This application is accessible in the URL that I mentioned lately, and it's also accessible on Stackblitz and on my GitHub repository, so you will be able to find it details there. So let's see what approaches we can have. The first simple approach is the one that every one of us, when they were starting with Angular, were implementing, and it's just injecting all needed services to our component and then grab all the data we needed. So let's see how it looks. Here is this simple approach. We can filter data, we can paginate it. We can see this loading indicator here when we change anything about filtering or pagination. We can enter error phrase in search to cause an error. That's the secret phrase that does it. So at the first glance, it all works. But how it's implemented? We can use in each of those examples the show source button to see the most important parts of the code related to the given approach. So in the service-based approach, I just connect our smart component to the Angular router, nothing special here. But when we see this component in action, we see that it injects all required services, and then it defines the state we'll be using in template by 4 properties. First property is params, which will hold parameters used for data filtering and pagination. Then we have launches property, which will contain the list of launches to be rendered. Then we have a status property. So it could be an idle state, it could be an error status, or it could be a loading status. And there will be an information about total number of results that are there on the API level. So there might be more data than is actually rendered. It's due to the pagination. So yeah, here I'm using ng-on-init lifecycle hook to start with loading launches, and I use snapshot from the activated route to read query parameters, because one of the requirements I was also having in mind is that all those parameters, so for instance, if I search something or paginate, will go to the URL. So we can actually copy this URL, pass it to someone else, and the other user will end up in the same place in the list. I think that for the listing views, this is very useful feature. We should not forget about it. Okay, so going back to the sources, here I call the getLaunches method. I use a function called queryParams to launchParams, which maps the query parameters from the URL to the parameters that will be accepted by the service, which will be fetching data for us. This method will be used in every approach as a mapper that provides that mapping of parameters. So getLaunches function does a lot of things, which is not great, but it works. So it sets parameters, it sets status to loading, and then we start making an HTTP request with the launch service and the getLaunches method. So this may result in having a new data. So that's why I'm using here the tab operator to switch the status to the idle again, because the request is finished. And in case of error, I'm switching to the error status. And as I don't want to present invalid data in the view in case of error, then I'm using the catch error operator to return an object which will have empty data list and total set to 0. And finally, this object, or the one returned by the get launches function from the service, will be used to set up the launches list and the total. So these properties, params, status, launches, and total, are used as an inputs to the presentational components. We have 3 of them here: the filters component, the list component, and the pagination component. These will be presentational components that will be used in all of the approaches I will present. So if we need to do any filtering here, or we need to change the page, we are using the outputs to call filter launches function or page launches function in our component. And as you can see, it does 2 things. One, it navigates. It is updating the query params in our URL. So if I refresh page, I will end up in the same place I was. And the second thing is, again, calling and launches here to fetch the data I want. So that's all. It's not that complicated. It has a reasonable amount of code, but it could easily turn into mess if we go with many more features that could be added to this list. So pros for using this approach: this is very basic approach for newbies, definitely, because we don't need any knowledge related to RxJS or signals here. So it's easy to get started. Data is stored within the plain properties, so it's easily accessible, no subscribes, which would make this a bit more difficult. But from the cons, we are using here declarative approach. So the state is defined manually. We retrieve the data and we have to set this property, that property, and so on. And if we miss something, then we have some troubles in our state, some inconsistent data. Another con is that everything is defined here in one place. So as I said, it can be turned into mess pretty easily. So this is the first simple approach. Let's see another one. Another one will be based on the resolver functions. So we can actually use Angular resolvers to move fetching data from our smart components into those resolver functions. So this, by default, is based on the handling parameters from the URL. So each time we'll change some query params in the URL, such a resolver will be executed and will deliver data to our smart component. It could be delivered in 2 ways. First, through the activated route object, which exposes data observable. But we can also use the new feature that was added in the Angular 16 version, which is component input binding. And resolver can deliver data to our smart component through inputs, as we will see in the example. So let's see it. Let's see if it works. CRS again. Let's change the page. Okay, it seems that it works. We can see updated parameters in the URL. So let's see at the source. So in order to start working with these component input bindings that were added in Angular 16, in the router configuration, we need to call with component input binding method, or if we are implementing the module-based application, there is an option called bind input to component or something like that. I would need to check the documentation. But it's available in both cases. So having that, we can start changing the configuration of our route. We have here the smart component connected to this route, and we need to define the property called run guards and resolvers and set the value to params or query params change. That means that if any parameter of the route or query param is changed, then all those resolvers have to be rerun by the Angular. So that's why in our smart component, we'll not be focusing on fetching data, we'll be focusing just on navigation, and this navigation will cause running resolvers that will provide us with the new data. So let's see how these resolvers connected to the resolve property looks like. So here I have an object which actually exposes functions that are also available here from the Angular 15, I guess. We can implement resolvers as a functions, much simpler than the class-based approach. So first resolver called params is taking query parameters from the activated route snapshot and maps that query params to my launch params that will be needed in the view for the filter component, and that params will be also needed for fetching data here. So second resolver here is the launches data, and this resolver also works with the activated route snapshot, but it also injects the launch service, as we can use inject function here to use the service. So I'm calling the get launches function, call this resolver here to have not just the query params, but the params that can be passed to the get launches method. And I exposed both to resolvers in the launch resolvers object and connect that to the resolve property on the route. So that will handle data fetching and providing the params to the view. So let's see how we can read it. So I'm using this component input binding feature. So in my smart component, I have two inputs, params, which will hold launch params, and I have input called launches data, but I'm using here a setter approach because I don't want to store just launches data. I'm using this setter as a distribution point to take data and total and pass it to the launches and total property, which are defined here. As I mentioned earlier, filter and launches and page launches functions that are used for handling outputs from the presentational components are focusing only on navigation. We do the navigation, and the rest of fetching data is handled with the resolvers. Here in the navigate function, we can also work with the status property. Because we are fetching data somewhere else, we can actually mark this loading state as based on the navigation, because within the navigation, which will take some time here because we are using resolvers, we can at the start mark the status as loading, then try to navigate, and when this navigation is successful, then we'll, based on this promise, set back the status to idle. And if navigation fails, and it will fail if any of the resolvers fail, we can catch that issue, catch this error, and set status to error, and clean the list of launches and set total to 0. So to show you that it works, I will also type error here And yes, loading is failed. Okay. And that's it. Not that much code here. So let's see what are the pros and cons of that solution. So again, with this computed input binding, component input binding feature enabled, still no knowledge of RxJS or signals is required, so it's easy to get started. Data is stored still in the plain properties, so it's easily accessible. Fetching logic is moved out of the component. It's in the resolvers, so that improved a bit the readability of our component. But we have to keep in mind that if a resolver fails, then navigation is cancelled. So we can, for instance, not enter our smart component if we were in the different place in the app. And we can leverage the reactive approach when we not use the component input binding, but rather use the activated route object and its data observable. From there, we can use RxJS operators to fetch the parts of the state we need. So that's the pros and cons for the resolvers. Up next is RxJS observables and using async pipe within our templates of the components. So here I will add additional element to this whole picture, which will be a component provider, a middleman service, which will handle requests from the smart component and translate them into the actions to the services we need. And it will expose the state through the observables. So the smart component would be much cleaner, and all the business logic would be hidden in such a service, which will be delivered, which will be provided on the components level. So let's see how it works. We have this RxJS async approach. See if it works. It's still working. Nothing changed from the yesterday. I didn't break anything here. So let's see how it looks from the code point of view. Nothing special regarding the route definition. And let's see now the async-based service. So this service in the middle. It injects all the required services we'll use, and it exposes status here as a behavior subject. So the initial value here is idle. I'm using in the line 20 the activated routes query params observable to fetch information about launch params. Here I'm observing query parameters and map them with my query params to launch params method. But that's not all. In the line 24, I'm reusing these params observable that I defined in the line 20, and I'm going further. I use debounce time here to delay a bit requesting data in case query params would be changed very fast. Then in the tab operator, I'm switching the current status to loading, and I'm using switch map to switch to fetching launches based on the given parameters. If it succeeds, I'm switching back to the idle state. If it fails, I'm setting the error status, and I'm catching that error. At the end, in the line 36, I'm using the share replay operator to multicast the data fetched through this service. So when I will have the more subscribers for the launches and totals, which are using the launches data defined here, they will not cause additional HTTP requests. So in the line 39, I'm defining the Launches observable, it takes launches data and just picks data from it. The same goes for total, it picks up the total property. And we have here two functions, filter launches and page launches, which change the parameters for that view by causing the navigation. And if we navigate here, the new value for query params will appear in this observable. So again, every observable will be here recalculated reactively. So that's it in this middle service. So let's see at the smart component. It injects the async-based service, and it just takes references to previously created observables. So params takes params, launches takes launches, and so on. We have filter launches function here and page launches that pass parameters that were provided through the outputs to our middle service, to our component provider. So in this implementation, such a smart component is clean and all the logic is moved to the async-based service. Since we are working with the observables here, we will use async in the template. So we don't have a manual subscriptions in the components class that we would need to take care of in case of unsubscribing. So we are using async here. And one, let's say, issue with async is that it in typing, it assumes that the result of the subscriptions would be, in that case, params or null. And I, as a creator, know that there will be no null here. It cannot be, because I'm all based on the query parameters. And this is the type of the observable that emits value upon subscription. So we'll have data for params instantly. Same will go for the launches and total, as I use here start with operator. So I need to use here exclamation mark, which is non-null assertion operator. And it tells Angular that I know what I'm doing and there will be no null here. That's basically it. Okay, so yeah, async here, async there, async everywhere in that template, and it works. Okay, so let's go to another example. Or maybe before that, let's see the pros and cons of this RxJS observable concept and using the async. So finally, we have reactive approach. So state is derived from the view params. State management logic is completely moved out of the component. We are using RxJS operators, so each observable is very easily extensible. There is this one issue I mentioned about using the async pipe and the null case. And one drawback here is that we are using observables, so we cannot easily fetch data like synchronously of the observable to see what's the current value. I mean, it's possible for the behavior subject, so we could also instantly check for status value in that case, but all other properties or other observables would require subscription. So that's the one drawback of using observables here. Next one, signals. This will be very similar to the RxJS approach. We'll have this service in the middle again, but everything will be based on signals. So let's see if it works at the beginning. So again, maybe now let's search for Falcon. There were some missions related to the Falcon SAT, Falcon 9 test flight, Falcon Heavy. Okay, so that works. Pagination works. Handling errors works. Okay, so let's see the source. Nothing special about the routing here. All the goodie is inside the signal-based service. So again, we are injecting all those services we need. And we start by making a query params signal. And here I'm using the toSignal function from the RxJS signals RxJS interop module. So that converts observable into signal. And I'm using here a flag called requires sync set to true. That basically means that this signal will have value at the beginning because the query params emits upon the subscription. So we'll have this value immediately. Then I'm using this signal in, for instance, line 23 to describe the computed signal called params, which is using my mapper and maps the router query parameters to my launch parameters, my launch params. In the line 21, I'm using the writable signal that will hold the current status. At the beginning, it's idle. In the line 25, I'm defining another writable signal, which will hold the info about the data and the total. And that one is a bit tricky to handle. Because I will use parameters and HTTP requests to fetch the data, I needed to introduce an effect, and signals effect that will react upon the params change. So in that case, when the params are changed, I'm setting the status to loading, and I'm making this HTTP request, updating status after this request. And upon subscription here, when data arrives, I'm writing new value to the readable signal, which is launches data, and set it to the result of this request. And that's not available by default. If I remove that configuration here in the options, okay, I forgot it's not editor and I cannot edit the static page. Sorry. If I would remove this configuration, basically Angular will find out that I'm setting data, setting other signals within this effect, and it will scream with errors at me, because according to the documentation, effect should not be used for defining values for the signals, as it may result in some errors. Even this famous one, expression has changed after being checked. But this is the easiest way to handle this HTTP request case based on the parameters, and it works without raising any errors. So there is this option for some purpose, and I'm using that purpose. Okay, so as a result of this HTTP call, I'm setting this launches data signal, and this signal is used by the computed signals here, launches and total, which basically picks data or total properties from this launches data signal. Again, filter launches and page launches are focused only on navigation, and everything starts from changing route params. Okay, let's see how it's used in the component. So again, I'm injecting the signal-based service. I'm passing the references to the state parts I'm interested in. So this looks like the thing we did with the RxJS approach, but the biggest difference is here in the template. we are not using async pipes. We are just calling those signals, and it's there. The current value of each signal is being delivered to the input of every presentational component there. And it works pretty smoothly. So to summarize this approach, again, we have this reactive approach. So state is derived from view params. State management logic is still out of the component, which is nice. Another benefit is that signal can be called for current value as a function without parameters. So this is very easily accessible. And as a cons, maybe this non-trivial integration with parameterized HTTP requests. It can be done in the effects. On the other hand, we can read in the documentation we should not do that unless we are pretty sure what we do. So we have to be sure what we do and do that. So that's the new approach with signals. Another approach we can take is the heaviest one from all of things we already seen. So we can use NGRX store library to store data globally. We can call actions through our components to cause data changing in the reducers by the reducers on the store. And those actions can also cause some effects that will be able to work with our data services. So let's see how it works there. We have this NGRX store to show you that this is actually NGRX store. I'm going to open the Redux DevTools. So as you can see, I have my application opened. The first action here related to launches was load, and it loaded some data because of the running effects, and the result of it was stored to the store. And if I want to use pagination here, for instance, show the second page of the results, I'm calling the page action, which calls the navigation here. I'm using the NGRX router store library. And this will cause the calling of the load action. All right. So let's see how it looks from the code perspective. So the setup is heavy, as I said. We use all of the goodies that are provided related to the store from the NGRX. So here I'm providing the store. I'm providing the router store, as I wanted to track the routing actions and use router selectors for fetching the query parameters data. I'm using effects, and I'm using the store DevTools, so I could have better experience with debugging. So nothing special about the main route here, or is it? I'm using here load children. One of my requirements here was to lazy load the entire reducer and the effects related to the launches. So I did a global route called store, and underneath it loaded with the lazy loading the new collection of routes, which was basically the empty route that was using the stored base component, the smart component. And here I'm with the providers registering the launches reducer and launches effects. So thanks to that combination, it could be lazy loaded. Let's see the actions definitions. So here I'm using the helper called create action group to to create actions related to launches, and there will be 5 actions here. The load action that would accept the launch parameters, the load success that will have response data in the payload, the load error in case fetching data will fail, and filter and page actions, which will have parameters related to the launches filtering or page settings. In another file, I'm using create feature helper to create both reducer and selectors related to my launches feature. So I'm providing here the name of the feature, and in the reducer property, I'm creating a reducer with the create reducer helper. So I'm also using here NGRX entity adapter to have methods that would help me with data manipulation, and adapter also will provide me some built-in selectors that I will be able to use. So here I set in the first parameter the initial state, and then I will handle actions. So first action I will handle is load. When load is called, I'm setting the status to loading. When load success is called, I'm storing the information through the adapter about fetched data, about space flights, and I'm setting the status to idle. And on the load error action, I clean the table of the launches, and I set error as a new status. In the line 30, I'm creating additional selectors that will be used by this feature. So here I'm using the getRouterSelectors method. It's provided by the NGRX router store and gives us selectors for the params, for the query parameters, for the fragment from the URL, all the stuff basically you would get from the activated route. And then I'm returning object of additional selectors, which will be the ones provided by the NGRX entity adapter, and one mine selector created by hand, which will be select params that will use mapping from the router query parameters to the launches params. That are not all selectors, because this create feature function already creates dynamically selectors by the initial state. So if I have these data total or status properties within the state, it automatically will create selectors called select data total or select status. So a bit of metaprogramming is done there. So here we have defined selectors and reducers, and finally we have effects. Here I'm using the new approach, functional effects that were added in the NGRX 16, which was released just right after releasing Angular 16. So here in the create effect method, I can provide a function that does injection in the parameters. And then in the handle params effect, I'm listening for action called router navigation action. This is action provided by the NGRX router store. So I can catch here the navigation actions, and there in the line 15 is one line that I don't like that much, but I had to do this because I was interested only in navigating within this view related to the store. So only this navigation here, not going to signals or somewhere else. Okay, so I filtered additionally those events here, And with this payload I had from this action, I used a switch map to switch to the current parameters taken from the select params selector and cause another action, which is load, passing those parameters that are needed for data fetching. This load launches effect is defined a few lines below. It injects also the launch service. So I'm here listening for the load action. And when it happens, I take those parameters from the payload and I make the HTTP request for launches. If it succeeds, I return the load success action. And if it's not successful, I'm using the load error method. And I have two additional effects defined here related to filtering launches and changing page of launches. They are basically making the navigation. Here, they are not dispatching any further actions. So, a lot of boilerplate to start with, but finally, let's go with using that. So in the smart component, I inject store, and from the NGRX 16 version, I have this function called select signal. So I can use previously created selectors to provide a signal in the smart component. I can use an observable approach by using a select function, but I can also use, as you can see, select signal. Then I use those signals within the template, so no using asyncs anymore. We can use signals and it looks much better. All right, so that's it for the RxJS approach. Let's see pros and cons. So we still have this reactive approach which we really like. State is derived from the view params. We have a very standardized solution. We have actions, effects, reducers, selectors. So if our team is familiar with the concept, they will be it will be much easier for them to understand with those elements that they are already know. We have a great support from the store DevTools, which makes our debugging easier. Selectors support observables and signals. And one point is that it requires a lot of code, as you've seen. So this is like, it could be, we can look at it as a drawback, but I look at it like a consequence of choosing this approach. Okay. And that's all from all the, let's say, normal approaches. We have last one, which is ultimate. Ultimate approach, which will be presented here, is heavily based on the RxJS and using the viewChild decorator to fetch the instances of the presentational components directly into the smart component class. So let's see if it works at the beginning. So let's search. Okay, search works, pagination works, error handling works. Okay, looks nice. So let's see how this is implemented. Nothing special in the route definition, and all the magic is defined here in the smart component. Actually, this component contains no methods. It just exposes one property called state, and it has all we need. So here I'm using viewChild to get the pagination component and the filters component, which are rendered there. And here in the NGO init, when we have access to those presentational components, I'm making this huge observable. So we want to trigger an event at the beginning, and then on every emission of the event from the filters, from the filter component on the paginator component. If filter output or page output emits a new event, we cause the navigation. And when this navigation is done, we are using a map operator to map new query parameters taken from the route snapshot and map it into the launch params. Then we take these launch params, and in the switch map, we are making the request for launches. And then in the result of this operation, we expose the new state here with the params, launches, new total, and the status. We handle the errors if they arise. And we have here some start with operator to provide the initial state when the data is starting to being loaded. And we are using share replay again here, operator, to multicast this observable. So these 5 subscriptions that I did in the template will reuse the same data provided by the get launches method. So it's all done within the single observable. So we have this reactive approach that is derived still from the view params. We have the smallest amount of code from all these approaches we've seen, but is it readable? Maybe not. Maybe it's only understandable for the RxJS wizards. We have to think of that the working solution is not the only criteria of a good solution. We need to focus also on providing things that will be easy to understand for other developers. So this ultimate approach is implemented for fun to show you that we can do a lot with the RxJS, but in the real life, I would not use such an approach. Finally, conclusions. So I have to say that there are no best approaches. We have different approaches. You can choose whatever you like, whatever is most suitable for your project, for your team, because if you want to implement an NGRX store, it doesn't mean that your team wants that and will have this willing to understand and learn NGRX. However, there are best practices which you can follow at any time. It's don't repeat yourself, keep it simple, separation of concerns, and so much more. So each approach is different, and it's up to you to select which one works for you. Another conclusion that it's taken from this implementation of examples is that signals are very great, have a great potential. We know that it's still under development, so there are still missing parts. Some parts are confusing. RxJS is here for long. It will be here for long, but I can imagine that signals in the nearest future will be upgraded, still developed, and in some point it would be a very good standalone solution that could be used with RxJS or without it. Okay, that's it. Thank you for your patience. As I said, you can access this app online. We'll post the link in the comments soon. And if you want to learn about me more or my workshops, you can go into the Angular in Space PL website. Okay, that's it. And do we have any questions here? Okay, let me go from the beginning. Okay, I see that there were discussions about setters, presentational component versus setter. this is something that I was mentioning on the second slide, or the third one. So presentational ones use inputs and outputs to communicate with the world, and smart components, also known as containers, they are using services to fetch data or to delegate data modifications. Some authors call that smart components pages. Someone else calls it view. In some articles, we could also see controller name. So it has a lot of different names. Another way to use content projection to pass data to our child component. Child component can use the ng content tag to accept some markup that is provided by the parent. It could be used through the content child decorator, so we can actually read that content, but for the passing simple data, I guess inputs are the most suitable solution here. Functional guards are also possible instead of class ones. The class ones are already deprecated. Danish asked if this will be available for watch later. I hope so. It's recorded. We'll see. It would be helpful. Live streaming, it will be available on YouTube. So, okay. The answer was in the next comment. We can use retry operator to retry the HTTP requests upon failing. Sure. Adrian asked for the Signal example. What if I don't need the response data anymore? Do I need to implement some take until or restore to default feature by myself for signals? No, take until is only present for the RxJS observables, and in case of this my example, we have only one subscription here in the effect, and it's only an observable which results in the single event, and that basically it's it closes the observable and completes that. So there's nothing to unsubscribe from. And no further questions. Okay. So again, thank you very much, and have a good luck on your projects, and hopefully you will find something useful from this presentation and implement that in your project. Thanks.
Thank you, Tomasz, for a great talk. I can see from your background that you don't only know something about Angular, but also in space. So Angular in space is a great name for that. Thank you guys for joining today. I would like to recommend filling out our survey, just to fill in the questionnaire that what you like or what you didn't like or what you would like to change in the future, so we can be improved, and the meetings will be improved in the future for you, because you are the part of the community. I would also like you to subscribe to Facebook, YouTube channel, Twitter, what you prefer in general, to be informed for the future meetings, because sometimes they happen also here in Poland, in Warsaw, and it's a great place for having a networking. We had a really great talk today. really great topics from Dawid and then from Tomasz, touching signals, I would say. Maybe it's not enough to say. Those are sometimes controversial, sometimes they're obvious, but that makes our great framework really, really nice thing to work with. So yeah, thank you for today, guys, and hopefully we see each other on the next meetup, and we'll provide you even more and more good quality content from community to another community members. So thank you, guys, and take care. Bye.